Hello. Today I am making a simple port scanner in Python. I start by creating a new file called port scanner. The first thing I do is import the socket module, which is going to be the foundation of this port scanner. The socket module in Python gives access to the network interface. It lets us create socket objects that can send and receive data across a network. It essentially acts as the bridge between our Python program and the network. We'll be using this module to try and establish connections to different ports on a target IP address, and we'll see if those ports are open or closed. I make the variables first here just to keep them in mind as I make the function. These will all be inputs, so we can specify them each separate time we run the program. The host variable holds the target IP address that I want to scan. I specify IPv4 because the socket will specifically be IPv4. Then port start and port end define the range of ports that we're going to scan. Now let's define the scanner function. This function takes host, port start, and port end as parameters. So inside the function I use a loop to go through the range of ports, starting at port start and ending at port end. Then I add +1 to port end to make sure the last port is included in the scan. If you don't do this, it will stop one short. Now the heart of this function is the socket setup. So I create a variable sSocket using socket AFINET, which specifies that I'm using IPv4 addressing, and socket sockstream, which specifies that I'm using TCP. This setup allows me to perform a TCP port scan. For UDP, the constant would be sock dgram instead of stream. I also set a timeout for the socket connection to ensure that the scan doesn't hang around indefinitely if a port doesn't respond. This timeout determines how long the scanner waits before moving on to the next port. So in this case it's 1 second. Now we'll set up a try block. I set the test variable. For each port in the range, I attempt to connect using the connectX method, whose parameters align with our inputs, host and port. Then a truth test. If the connection is successful, indicated by a 0 from connectX, it will print that the port is open. And if we get any other value than 0 from connectX, it's false. The port is closed. So we can take a look at printing that, but in a minute I will show you why we may not want to do that. So I'll comment out continue here for later. As a catch-all for error handling, we'll do except port unreachable. This might be common on a firewall that won't want to send information to a port scanner like this one. So instead of returning that the port is closed, they just silently drop it. This makes it appear as if the port is unreachable or doesn't exist at all. Our except block is designed to catch these scenarios where the connection attempt fails, either from silently dropped by a firewall or network issue or other errors, so the scanner will continue to run. And finally, let's ensure that the socket is closed after each attempt. It's just a good practice to avoid leaving open connections. And now we will call the function. We put in our input variables for the parameters. So the scanner is finished, and let's try it out. I put in the loopback address of 127.0.0.1, and oops, we got an error. Forgot a T there. So we can test it out. We'll just do 10 ports and no errors. Now let's scan the full range of ports from 1 to 65,535. And you'll see the output can be overwhelming. So even trying to find anything is difficult. So let's set the scanner to only print open ports. This will make it much more manageable. And we'll comment out the print for closed ports and put in the continue, which will continue the loop through our port range without printing anything. So let's run that again with the loopback address and a full port range, 1 to 65,535. And we see that port 631 is open, which happens to be Internet Printing Protocol. And just to validate our efforts, let's compare them to the gold standard port scanner Nmap. And let's see what Nmap comes up with. We'll use the same loopback address. And there we go, also 631. So I can reasonably assume that the Python port scanner is working correctly.